A little shuttle that could, Explorer 2, is setting out toward its nearest experience. However, with Neptune now billions of miles from Earth, Neptune is the eighth marvel of our planetary group. No other heavenly body matches this planet's greatness. Furthermore, alarming highlights aside, Neptune's once captivating storyline has taken a plunge as something is amiss with the ice giant. A few cosmologists had cautioned us quite a while ago, but initially, researchers couldn't pinpoint the issue since they were more captivated with the capability of life on the planet. The issue has gotten out of hand, and now researchers are battling to fix it, particularly considering Neptune's vast distance from Earth. What stunning revelation about Neptune has researchers so stressed? Might it be connected to the reputed SeaWorld underneath Neptune or its largest moon, Triton? Join us as we investigate how something horrible is happening to Neptune in 2024 and nobody knows why. Researchers have forever been charmed by Neptune, endeavoring to explore the floods of mystery surrounding the planet to uncover new realities. For years, we've been contemplating this astonishing planet, and almost every day we coincidentally find a shining discovery, demonstrating there are still a myriad of secret marvels in Neptune. It was the quest for these secret wonders that drove space experts to a stunning new discovery. Something is off with Neptune. Scratch that. Something horrendous is going on with the sparkling icy planet, and researchers can't shake the image of this distressing event from their minds. However, we can't talk about this emerging issue without first recognizing Neptune for being an astounding planet. If all the planets in the solar system were to gather for a family meeting, Neptune's presence would be the most imposing. Indeed, even without saying a word, the planet significantly affects neighboring planets and the astronomers who observe it. Standing firm as the eighth planet in the solar system, Neptune belongs to the group of giant planets. Yet the planet wasn't satisfied with this grouping and chose to specialize down to another subfamily known as ice giants. Neptune is an ice giant and shares this distinction with its close twin Uranus. In diameter, it is the fourth largest in the solar system. Another distinguishing feature is that it is the third most massive planet and the densest giant planet in our universe. When compared side by side, Neptune edges out Uranus by being somewhat more massive. If Earth were to join the competition, we would see that Neptune is multiple times the size of Earth. While the average person may be stunned by this data, scientists have unique considerations. Many researchers have speculated about the possibility of living on Neptune. The planet's immense size means there is enough room for it to potentially act as a habitable environment if we ever confirm it can support human life. While we contemplate this notion, we should mention that the planet's equatorial diameter is 24,764 kilometers, almost 4 times that of Earth. Once again, Neptune demonstrates its superiority over our planet. Neptune continues its streak of achievements with a surface gravity of 1.14 times that of Earth's surface gravity. The only planet superior in this class is the well-known Jupiter. Many researchers have admitted that exploring Neptune feels different, almost as though they are walking through El Dorado. This feeling is heightened by the fact that Neptune introduces them to a world so different from Earth. Additionally, it is difficult to observe Neptune with the naked eye. In the early years of the planet's discovery, we had to rely on our intellect and mathematical predictions. However, over the years, we've gradually peeled away the layers of mystery surrounding this planet. This journey began on September 23, 1846, when Johann Galle first observed the giant planet using a telescope, marking the start of a series of observations. The turning point in our understanding of Neptune came in August 1989 when the Voyager 2 spacecraft flew by the planet. The space probe gave us a clearer image of this surprising planet and opened up new possibilities we never knew existed. We've been able to explore some of these possibilities thanks to advanced space equipment like the Hubble Space Telescope, HST, and the James Webb Space Telescope, JWST. Despite being a few billion kilometers from Earth, the HST and JWST have continuously sent back data from various space observations. Over time, Neptune has consistently featured in this data. When researchers examined these images, they discovered something exciting about Neptune's internal structure. They couldn't contain their excitement upon realizing that Neptune's interior structure is quite similar to Uranus, confirming that Neptune is indeed Uranus' twin. Further examination of the data showed that Neptune's atmosphere accounts for 5 to 10% of its mass, and the core is composed of iron, nickel, and silica. This finding left researchers puzzled, as we can't survive in such extreme conditions. It is a very hostile environment for human life, particularly given the dominant winds with speeds ranging from 20 meters per second in the easterly direction to 325 meters per second in the westerly direction. Even if we marvelously find a potential habitat on Neptune, we can't overlook the fact that most of the winds move in the opposite direction to the planet's rotation. Researchers were still bewildered by this finding when another revelation landed in their laps. Space observations uncovered a staggering amount of methane, ethane, and acetylene at Neptune's equator, 10 to 100 times more than at the poles. Moreover, Neptune is plagued by seasonal changes, causing the cloud bands in the southern hemisphere to increase in size. Scientists have admitted that there is a direct connection between Neptune's long orbital period and why its seasons last 40 years. As of today, Neptune is the farthest planet in the solar system and maintains a very distant relationship with the Sun at 4.5 billion kilometers away. Every 165 Earth years, the planet completes its orbit around the Sun. Despite this distant relationship, Neptune still receives energy from the Sun but emits twice as much energy as it receives. This observation has stunned researchers as they can't explain how a planet that is more than twice as far from the Sun and receives only 40% of its sunlight has enough internal energy to drive the fastest planetary winds in the solar system. They are further puzzled by the fact that Neptune is hotter than Uranus, even though Uranus should be hotter due to its closer distance to the Sun. However, this is not the case. In the upper regions of Neptune's lower atmosphere, temperatures can drop to 50 K, and at a depth where atmospheric pressure reaches 1 bar, the temperature is 72 K. If we travel further down into the deeper layers of gas, the temperature rises steadily. Researchers are still recovering from the shock of Neptune being hotter than Uranus despite being farther from the Sun. As they ponder these questions, they are hit with more astonishing revelations from Triton, Neptune's moon. In the realm of natural satellites, Triton stands tall. It is the largest natural satellite of Neptune and the first to be discovered. At around 4.5 billion kilometers from the Sun and just shy of 4.4 billion kilometers from Earth, Triton is challenging to observe using telescopes. However, the 1989 Voyager 2 flyby provided valuable insights. A little shuttle that could, Explorer 2, is setting out toward its nearest experience. However, with Neptune now billions of miles from Earth, Neptune is the 8th marvel of our planetary group. No other heavenly body matches this planet's greatness. Furthermore, alarming highlights aside, Neptune's once captivating storyline has taken a plunge as something is amiss with the ice giant. To delve deeper into Neptune and its intriguing mysteries, let's explore further aspects of this distant world that continue to captivate scientists and enthusiasts alike. Neptune's magnetic field is one of the most complex in the solar system. Unlike Earth, which has a relatively simple dipole magnetic field, Neptune's magnetic field is tilted at an angle of about 47 degrees from its rotational axis and is significantly offset from the planet's center. This means that Neptune's magnetic field is not aligned with its rotation axis, which leads to a highly irregular and asymmetric field. This unusual magnetic field could be a result of a combination of factors including the planet's internal dynamics and the presence of a fluid metallic hydrogen layer deep within its core. The magnetic field plays a crucial role in generating Neptune's intense radiation belts and influencing its atmospheric conditions. Another compelling feature of Neptune is its system of rings. Although not as prominent as Saturn's rings, Neptune's ring system is composed of faint, narrow rings that were first observed by the Voyager 2 spacecraft. These rings are made up of ice particles, dust, and possibly small moons that orbit within the rings. The rings are classified into 5 main rings: the Adams, Leverrier, Gale, Arago, and Lassell rings. They are named after the astronomers who contributed to the study of Neptune. The discovery of Neptune's rings has provided valuable insights into the dynamics of ring systems and the processes that shape them. One of the most enigmatic aspects of Neptune's atmosphere is its mysterious dark spots. These spots, similar to Jupiter's Great Red Spot, are large, dark, and storm-like systems that can persist for several years. The most famous of these is the Great Dark Spot, which was observed by Voyager 2 during its flyby in 1989. These dark spots are thought to be high-pressure systems with high-altitude clouds that absorb more sunlight than their surroundings. The precise nature of these spots and their dynamics remain subjects of ongoing research. They provide clues about the atmospheric circulation patterns and the meteorological phenomena occurring on Neptune. Triton, Neptune's largest moon, is another source of fascination. It is one of the few moons in the solar system that orbits its planet in a retrograde direction, meaning it orbits in the opposite direction of Neptune's rotation. This suggests that Triton might be a captured object, possibly a dwarf planet or an icy body from the Kuiper belt that was gravitationally captured by Neptune. Triton is unique for its geysers, which eject nitrogen gas and dust into space, creating a thin, hazy atmosphere. The presence of geysers indicates that Triton has some form of internal heat or geological activity, making it a prime candidate for studying the potential for cryovolcanism or ice volcanoes. In addition to Triton, Neptune has several smaller moons, including Proteus, Nereid, and Larissa. Each of these moons has its own unique characteristics and orbits, contributing to our understanding of the diversity of natural satellites in the solar system. For example, Nereid has one of the most eccentric orbits of any moon in the solar system, which means its distance from Neptune varies significantly over time. This eccentricity may provide insights into the gravitational interactions between Neptune and its moons. The study of Neptune's atmosphere has revealed intriguing details about its composition and dynamics. Neptune's atmosphere is primarily composed of hydrogen, helium, and methane, which gives it its characteristic blue color. The presence of methane absorbs red light, allowing blue wavelengths to dominate. Observations have shown that Neptune has the strongest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour, 1,300 miles per hour. These winds contribute to the planet's dynamic weather patterns and contribute to the formation of its dark spots. Neptune's extreme weather and atmospheric conditions are a result of its complex climate system. The planet experiences large temperature variations, with temperatures in the upper atmosphere dropping to around -214 degrees Celsius, -353 degrees Fahrenheit. This is due to the low levels of solar energy it receives and the heat generated from its interior. Despite the cold, Neptune emits more energy than it receives from the sun, suggesting that there is some form of internal heat source driving its atmospheric processes. The study of Neptune's internal structure is challenging due to its great distance from Earth. However, researchers have employed various methods to probe the planet's interior. Observations from the Hubble Space Telescope and other instruments have provided valuable data about Neptune's thermal emission and gravitational field. These observations suggest that Neptune has a rocky core surrounded by a thick layer of icy and rocky materials, which is encased by a deep, turbulent atmosphere. The precise details of Neptune's interior remain uncertain, but ongoing research aims to refine our understanding of its composition and structure. In recent years, advances in technology have enabled scientists to study Neptune with greater precision. The development of new observational techniques and space missions has expanded our knowledge of this distant planet. For instance, the upcoming missions to the outer solar system, such as the planned James Webb Space Telescope observations and potential future flybys, promise to provide even more detailed data about Neptune's atmosphere, rings, and moons. The search for potential habitability on Neptune and its moons is an area of active research. While Neptune itself is too harsh for human life, its moons, particularly Triton, present interesting possibilities. Scientists are exploring the potential for life in the subsurface oceans that may exist beneath the icy crusts of these moons. The discovery of organic compounds and the presence of geysers on Triton suggest that there could be a more complex environment beneath the surface. These findings fuel the speculation that extraterrestrial life might exist in the outer solar system, and further exploration could reveal new and exciting possibilities. In conclusion, Neptune remains one of the most enigmatic and fascinating objects in our solar system. Its extreme weather, complex magnetic field, faint rings, and intriguing moons continue to challenge our understanding and drive scientific inquiry. As technology advances and new missions are launched, we are likely to uncover even more about this distant world and its role in the broader context of planetary science. The ongoing research and exploration of Neptune promise to shed light on many of the mysteries that surround this icy giant and contribute to our understanding of the outer reaches of our solar system.